So hello everyone, my name is Lucy Smith. I'm the TMDL coordinator out of the Blue Ridge Regional Office. And I was just going to give a quick overview of the Benthic Stressor tool that we've developed here in Bro. Just kind of go through the data that's working in the background and give a quick demo of the tool as it stands now. So there'll be some changes in the next year probably for this tool, but we just wanted to show quickly the tool where it stands. Emma Jones and Jason Hill and Mary Dale all have worked to develop this tool and provide the guidance document and tool information for us to use as well. So just a little bit of background on this tool, how we got here. It really started from the biomonitoring program self-assessment, where the biologists and TMDL coordinators kind of identified a need to have some guidance that helped us understand how the water quality data we were collecting kind of corresponded and drove the benthic communities that we were seeing. So really from the TMDL perspective, we were doing some benthic TMDLs and getting these stressor identification reports from contractors, but we didn't have a great way of evaluating the data ourselves or understanding what a high total nitrogen level was versus what a low one for these TMDL streams. So Chip Sparks, the biologist, one of the biologists in the Southwest Regional Office, took it upon himself and along with Mary and Jason to put together and develop these stressor thresholds for us to use to help guide some of these programs. So since that development of the stressor document, we've done a couple of workshops to introduce this concept, and the official document was posted on DEQ's website in 2017 and is available at this link here. But along with the guidance document, a companion spreadsheet was presented where you could enter the data from a stream of interest, like a TMDL stream, and it would calculate the median for your stream and your parameter, and it would compare it to the thresholds that were found across Virginia. And so since Emma's joined the team in 2015, she put it in our Markdown, our programming tool, so it's a little bit more user-friendly than the Excel spreadsheet. And since that time, we've been working to develop this Shiny application, which I'll demonstrate, and then also our Markdown document that's generated that kind of shows all of your data and in these tables that are color-coded by the stressor threshold. So really the data that goes behind, kind of working behind the scenes in the tool are this data from the probabilistic monitoring program. And these are stations that are randomly located across Virginia. And so that allows for a really robust and powerful data set because they are randomly located, we can do these statistically valid statements about water quality across Virginia. So we're not just looking at streams that are impaired or are really high quality reference streams, but we're just looking at everything in between, the good and the bad and the medium. So that allows us to make some broader statements about water quality in Virginia. It also allows us to calculate the relative risk and stressor extent for some of these parameters, and also allows us to do cool things like working with the BCG tool that Dr. Brent presented on Monday. The other neat thing about this data set is that the data is co-located with biological and chemical monitoring data. So it's we're not just collecting bugs when we go out there, but also collecting a suite of chemical parameters and some physical habitat data as well. So this probabilistic program has helped us kind of refine the list of candidate stressors that we see as most common in Virginia. And like we talked about again on Monday, we have some parameters that are going to have some physiological effects on organisms. So they'll have a lethal effect where an organism is without or is not within its range of these parameters, and so it can't persist in that environment. But we also have parameters that are have indirect effects. So things like sediment and can affect the habitat of a stream where the rocks aren't clean or don't have the interstitial spaces that are needed for some more sensitive taxa. And so rather than having a lethal effect on an organism, that organism is going to choose to move to a different habitat or is going to be outcompeted by other organisms that can withstand that condition more. Similarly, with nutrients here, we rarely find levels of nutrients that are toxic to organisms, but we do see some indirect effects by the changes in the food resources available for those organisms. So again, bugs that are able to use those food resources that are available are going to outcompete the ones that might have more restrictive dietary needs. And so again, the probabilistic program has shown us kind of what the top stressors are in Virginia. And so this is a figure that comes from the 2020 integrated report and shows us that really the big ones in Virginia are sedimentation and total phosphorus. So we see a lot of streams that are really kind of up there in their the threshold levels that we see there. But we also kind of have a suite of other parameters that we have smaller groups of streams that are on the upper end of those thresholds. So we use this information to help us develop these stressor thresholds. Again, it all starts with this really robust data set that we've collected for the past 20 years. And then we use that data set to define thresholds using some statistical techniques like quantile regressions and conditional probabilities and these change point analyses where we can identify a number for each parameter that we're looking at, a number where we see changes in the macroinvertebrate community across Virginia. And then the next step, once we've defined those thresholds, we can test them using some box and whisker plots and relative risk analyses to make sure they make sense across the state and that the macroinvertebrate data agrees with these thresholds as well. And then really the next step is to kind of categorize these parameters or to use them for comparing our own data. So calculating the median value for a stream of interest, and then we can categorize that parameter based on its probability for aquatic stress. So the result of this process are these tables here, these stressor threshold categories. And again, we can't create these thresholds for every parameter because we don't have that level of data, but the document goes into detail with about 11 of these different parameters, I think, that we have the amount of data that we can calculate these thresholds. So here we're just showing 6 of them, but what we see here is the probability for aquatic stress according to these numbers. So what these numbers are telling us is that for a stream that has a total phosphorus concentration that's greater than 0.1 milligrams per liter, in 90% of the streams that have that level of phosphorus, we see an impaired aquatic community. And so again, it's just a correlative analysis. So of course there could be other things going on, but this kind of data like raises a red flag for us that, hey, there's a lot more total phosphorus in this stream than what we see across Virginia. So it's kind of a good starting point, a good metric to stick inside of your stressor analysis report or into the CADIS structure to support what the stressor could be. But it's also important to remember that these different thresholds and these different parameters kind of vary by ecoregion. So here we have dissolved oxygen, and we can see that if you're working in the Blue Ridge Mountains, you're going to expect dissolved oxygen concentrations that are higher than if you're working in the southeastern plains. So if you are in the southeastern plains and you have a lot of observations that are in this yellow category, it might not be abnormal for that region. It could be a natural condition. So it's just important to remember where you are. But we also see variation in stream order as well. So less variation for DO and stream order, but other parameters are going to be different. And then also for the basin as well. So that's going to correlate with your ecoregion, but again, it's important to remember what kind of basin you're in and what levels of these different parameters you would expect. So the tool and the document will outline these different subpopulations for you to make sure that you're interpreting the data correctly. So now I'm just going to run through a couple of screenshots from our stressor tool here. Here's the link for the tool if you'd like to access it. You have to be on VPN in order for it to work. But I'll just run through a couple of slides here. And like we were saying Monday too, the data process is kind of changing in the agency. So EDAS, where the benthic data was once held, is moving or has moved into KEDS. So any more recent data within the last year is going to be, you're not going to be able to find it in EDAS. If you have older data, if it's a year or two old, it should still be in the EDAS database. And if that's the case, then you can walk through this, how to document and be able to pull that benthic data there. But in the future, we're going to try to hopefully connect to KEDS so that we can just have one streamlined tool where we can pull the benthic data and the water quality data as well and input it directly into this tool without having kind of the data wrangling steps in the background. And again, as well as the EDAS, the water quality data that's currently in Logi is going to change as well. So that's going to affect this tool and how the data comes in. So we created this data organization tab, which helps to wrangle the data so it is all in one nice clean spreadsheet for you to be able to upload into the tool. But like I said, that's changing, so I'm not going to go into a ton of detail about that, but it's got some pretty detailed directions here where we've created a couple of queries on Logi where you can pull the data that's needed and then input it directly into this tool. The next tab is this data upload tab, which we'll zoom into that. So here's what the data upload tab looks like. You can download your template here. So whatever data you put in has to meet this template, has to have the same column headings and the same data type. So just make sure whatever data type you're inputting that it matches this template exactly. But if you do that and you upload your data, it should come in nicely like this data set here. And you can just take a quick look and make sure everything came in correctly as you would expect. And then you want to, again, make sure you enter what your basin is, the ecoregion, and your stream order so that you're looking at the right CDF plots in the next tab. So the next tab is this data summary tab where you can go here to these sub tabs and take a more detailed look for any of these parameters. So if we click on this DO summary here, you can see it calculates an average and a median DO for all the data we've entered. And then it's going to highlight it with a color that corresponds to this risk category table down here. So what this is telling me is that there's the DO in the Roanoke River at this station is within background condition and has a no to low probability for aquatic stress. You can also then look at it in the context of the subpopulations, so where your data point falls out according to the percentiles in Virginia, the Roanoke Basin, and the Blue Ridge Mountains. And then if you want to see these cool CDF plots here, you can change which subpopulation you're looking at and see exactly where your data falls out according to that subpopulation. If you go to this composite table subtab here, you can download an HTML report that has all of these different subpopulations and all of the different parameters all in one document. So that's kind of nice to save to your project file, or you can send it to the landowner or someone who, your monitoring team, if you're still working on monitoring for this project, or even the contractor to take a look at what the tool is hinting at. So the next tab is the statewide map here. Again, it's just going to populate all of the probabilistic sites, and with the color, right now we're looking at DO again, but you can change the parameter that you're looking at. So you can have an idea, again, if you're in an ecoregion or in a basin that has a lot of these red and yellow colors, maybe it's not so abnormal that you have some low DO observations. But here in this basin, it looks like it probably would be kind of abnormal to have a yellow or medium probability DO value. This is also a good place to come to if you aren't sure of what your ecoregion is or your basin, because you can change what you're seeing here in this on this map to show the ecoregion. The next tab is this dissolved metals tab, which Emma added to kind of dig into the dissolved metals data. So it's good for TMDL and also assessment folks too, if you're interested in seeing if there are any exceedances. So you would upload another file. So the dissolved metals file is going to be a different data pool, but that has to meet this template again. So make sure the headings and column headings and data is the same. But you'll upload it and it'll populate your dissolved metals and show if there are any exceedances to the individual metals. So there is a threshold for metals CCU, which you need all of these individual metals to calculate that metal CCU, and the data organization tab will calculate that number for you as well. And then finally, the last tab is this report tab. And so what this does is it sucks in the data that you've already uploaded in the data upload step. And then you can add in the macroinvertebrate data. Again, it has to match this template, but you would upload it here and then upload the habitat data as well here in this upload box. And then you can change the name of your river, because there are places in the report that will auto-populate your river. So that just kind of saves you a little step there. But then you can generate your report depending on which parameter or which VSCI metric you're using. But you generate this report and it would produce a Word document that just has some examples for what your report might look like. So it just has some figures already created for you, some example text, and other information to look at. So it's just kind of a good starting point if you're writing your own stressor analysis, or you need some figures to put in a landowner report, or we've used this tool for delisting reports, or other just general information that you might want to show on this for this data. And then that, I think I am done, so we can have any questions here.
Okay, Emma, we do have a couple of questions. One is actually a comment. You touched on it when you mentioned the tables that you were producing through the tool. Someone notes that this tool is also useful for reports to landowners when requested.
Yeah, so you can, and I think it's in the pipeline maybe to create kind of a landowner report for pulling some data, but this kind of serves as a good substitute. Either that CDF report, you could pull that, or modify the final report as well to send it to a landowner.
Very good. Another question, are there any future plans to have stressor probability standardized on a regional basis?
Yeah, so that would be ideal for sure, to have some more specific thresholds across the state. So if you are in the coastal plain, you can really look at thresholds that are directly relatable to your streams. But unfortunately, we just don't have the amount of data we would need to do something like that, especially in regions like the coastal plain where we have just fewer sites that we're able to visit. So maybe that's something we can look at in the future, but as it stands now, we would just probably need to wait a couple more years to collect additional data to do that.
Okay, great. No more questions, it looks like, and I guess we'll be wrapping this up now. Thank you very much, Lucy. I really appreciate it. And thanks everybody for attending.